All right, class, this is the last video on section 6.5 in your note packet, definite integrals using the U substitution. And so we are picking it up at the top of page 92 with example 3, and we're going to do a couple examples applying the average value of a function to a couple word problems. So in example 3, you're given Android cell phones ad spending between 2010 and 2015 is given by this function s of t, for t equals 0 to t equals 6, where t equals 1 corresponds to the year 2010 and t equals 6 then corresponds to the year 2015. S of t is measured in billions of dollars and t is measured in years. You're asked what was the average spending per year on Android cell phone ads between 2010 and 2015. So this goes from t equals 1 to t equals 6. So A, in the average value of a function formula, A is equal to 1 and B is equal to 6. So to find the average spending using the average value of a function formula, we have average spending is equal to 1 over 6 minus 1 times the definite integral from 1 to 6 of the function up here s of t, which is equal to 0.68 times t to the 0.95 power with respect to t. Now this 0.68 is a multiplicative constant. It can be brought up from the definite integral. So we have 0.68 over 5 times the definite integral from 1 to 6 of t to the 0.95 power. And now we can just use the basic rule of antidifferentiation, the power function rule. We add 1 to the exponent, divide by the new exponent, and we get 1 over 1.95 times t to the 1.95 power. Right? 0.95 plus 1 is 1.95. 0.68 divided by 5 is equal to 0.136. So you notice because this is a word problem, right, we don't have the nice whole numbers that we're working with here. So 0.136 times 1 over 1.95 is equal to 0.136 over 1.95. And then when we put in the upper limit 6 in for t, we have 6 to the 1.95 power. And then we subtract and put in the lower limit 1 in for t, and we have minus 1 raised to 1.95 power. And using your calculator, when you evaluate this arithmetic expression is equal to 2.226. But in the context of this word problem, the average spending per year is $2.226 billion per year. This is the answer. And then if you multiply 2.226 by billion, right, then you can write the answer as this down here, $2,226,000,000 per year. All right. In example 4, you're given the government would like to cut gasoline usage from 140 billion gallons per year in 2007 to 128 billion gallons per year in 2017. The agency's projection of gasoline usage from the beginning of 2007 until the beginning of 2017 is given by this function, where t goes from 0 to 10. So t equals 0 corresponds to 2007, and t equals 10 corresponds to 2017. A of t is measured in billions of gallons per year, and t is in years with t equals 0 corresponding to 2007. According to the agency's projection, what will the gasoline consumption be at the beginning of 2017? But again, if t equals 0 corresponds to 2007, then t equals 10 corresponds to 2017. And so we evaluate this function at t equals 10 up here, and we have a of 10 is equal to 0.014 times 10 squared plus 1.93 times 10 plus 140. And when we evaluate that arithmetic expression, we get 160.7 billion gallons. So the projection is that gasoline consumption at the beginning of 2017 is 160.7 billion gallons. All right, in Part B, you're asked, what will the average consumption per year over the period of 2007 to 2017 be? So again, this is from t equals 0 to t equals 10. So A is equal to 0 and B is equal to 10 in the average value of a function formula. And so the average consumption per year is equal to 1 over 10 minus 1 times the definite integral from 0 to 10 of the function a of t up here. So this is a of t inside the definite integral. And then we find this antiderivative. So 1 over 10 minus 0, right, is just 1/10. And then we can find the antiderivative of this function term by term. The antiderivative of the first term is 0.014 divided by 3 times t cubed. The antiderivative of the second term is 1.93 divided by 2 times t squared. And the antiderivative of 140 is 140t. And the limits of integration are 0 and 10. So we put in the upper limit of integration in for t, and we have 1/10, right? So we put in 10 in for t here, 10 in for t here, and 10 for t here, and we have 1/10 times this in parentheses. And then we got to subtract and put in 0 in for t, right, the lower limit of integration. But when we put it 0 in for t, each of these three terms is equal to 0. And so we just end up subtracting 0, which I have not written out here. So now when you use your calculator, you evaluate this arithmetic expression. You get this arithmetic expression is equal to 150.1. So the average consumption per year over the period of 2007 to 2017 is 150.1 billion gallons per year. So this is the answer to the question here in Part B.